version of past equation A is what is meant by simple harmonic motion. Simple harmonic motion is defined as a periodic motion without loss of energy in which the acceleration of a body is directly proportional to its displacement. B. An object of mass 50 kg suspended from a spring undergoes a simple harmonic motion with a period of 6 seconds. The first question is calculate the angular velocity of the motion. Given the mass from the equation is 50 kg, the period is 6 seconds, and the frequency is 1 over 6 Hz. The first question, to find the angular velocity, we use the omega equal to 2 pi f and substitute the value into the equation, and we get 1.05 radian per second. The second question is, what additional mass should be added to the spring so that it oscillates with a period of 8 seconds? Given the period is 8 seconds, so the frequency for the second frequency is 1 over 8 Hz. We use the mass spring equation, and we get the 1 over 2 pi set k over m for the first equation, and after the mass added, the equation will be like this. Dividing equation 1 and 2 by substitute the value into the equation, and we get the additional mass is 38.9 kg. A 200 gram object is connected to a spring and move along the x-axis in a simple harmonic motion, where x in centimeter and t in seconds. Calculate the frequency of the motion, velocity of the object t equal to 2 seconds, acceleration of the object t equal to 2 seconds, and total energy of the system. Given the mass is 200 gram, we change to kilogram first, and this is the equation. Based on the equation given, omega is 0.4 pi, and we use omega equal to 2 pi f, and we just need to substitute the value into the equation, and we got 0.2 Hz. The next question, we need to find the velocity of the object at 2 seconds. So we just need to substitute the value into the equation, and we get the value of x. And we use the velocity equation, and we get plus minus 0.4836 centimeter per second. The third question, we need to find the acceleration of the object at 2 seconds. So we use a equal to negative omega squared x, and we just need to substitute the value into the equation, and we get 0.5041 centimeter per second square. So for the last question, we need to find the total energy. So we use total energy equation, we substitute the value into the equation, and we get 3.945 times 10 to the power of negative 6 joule.
So PSPM 2012 and 2013, number 2A, what is meant by simple harmonic motion? So simple harmonic motion is a periodic motion without loss of energy, which acceleration is directly proportional to the displacement from equilibrium and directed towards the equilibrium. So next is B. Figure 9.1 shows a displacement of a time graph of a simple harmonic motion. So the question is, determine the amplitude. So as we know, amplitude is the maximum displacement and also minimum displacement. So the amplitude is within the crest or the trough. So the amplitude is 5 centimeter, and we convert it to meter, equal to 0.05 meter. And the frequency is 1 over period. So the period is one complete oscillation is 4 seconds. So the frequency is 1 over 4, and we get 0.25 Hz or 0.25 per second. So third is the angular velocity. So we use the formula T equal to 2 pi over angular velocity, and we rearrange, and we got angular velocity equal to 2 pi over T. So we know the period is 4 seconds, and we just substitute it to the formula. So angular velocity equal to 2 pi over 4, and the answer is 0.5 pi radian per second. And the fourth one is equation for the simple harmonic motion is x equal to 0.05 sine 0.5 pi t. So where the amplitude is in meter and the angular velocity is in radian per second. Next is to see. The question is a 175 gram mass on a smooth surface is attached to a horizontal spring with a spring constant 8 Newton per meter. The mass is set to oscillate by pulling it 10 cm from its equilibrium position and release. Calculate the period of the oscillation. So we call out the information given. So the mass is 0.175 kilogram, and the spring constant is 8 Newton per meter, and the amplitude is 0.1 meter. So the first one, the period of oscillation. So we use the formula angular velocity equal to 2 pi over t. So and the spring constant is equal to mass times with angular velocity square. So we know the spring constant is 8 and the mass is 0.175 and the angular velocity is 2 pi over t square. So we rearrange and we get the period is 0.929 seconds. Next is maximum speed of the mass. So velocity maximum is equal to a omega. So v equal to 0.1 because the amplitude is 0.1 times with 2 pi over 0.929, and we get 0.676 meter per second. And the last one is total energy of the system. So energy equation is E equal to 1 over 2 m omega square s square. So we substitute all the information given into the formula and we will get the answer 0.04 joule. That's it from me today.
Number 6A. 1. What is determined by simple harmonic motion? Simple harmonic motion is a periodic motion without loss of energy in which the acceleration of a body is directly proportional to its displacement from the equilibrium position and is directed towards the equilibrium position but in opposite direction of the displacement. So number 2, is a bouncing ball an example of simple harmonic motion? Explain your answer. The answer is no, because the acceleration of the bouncing ball is not proportional to the displacement from an equilibrium position. So B, a particle in a simple harmonic motion along the x-axis start from the equilibrium position and move toward the right with an amplitude of 2 cm and a frequency of 1.5 Hz. So we take out the information which is amplitude A equal to 2 cm, which is 0.02 meter, and frequency equal to 1.5 Hz, and omega, we can find omega using 2 pi f, so the value is 3 pi radian second -1. So first question, write the simple harmonic equation of the particle, which is x equal to a sin omega t. So we substitute the value, we get 2 sin 3 pi t, where x is in centimeter and t in second. So number 2, calculate the maximum speed of the particle. So v maximum equal to a omega, which is 0.02 times with 3 pi, we get 0.19 meter per second. So number 3, calculate the acceleration of the particle at t equal to 3.2 seconds. So we substitute the t value 3.2 into the equation, which is 2 sin 3 pi 3 2. So we get negative 1.90 centimeter which is negative 0.019 meter. So the formula for the acceleration is A equal to negative omega square x. So we substitute the value, we get 1.69 meter second negative 2. So for question C, a 50-gram object connected to a spring with a spring constant 35 Newton meter per second oscillates with an amplitude 4 cm on the horizontal frictionless surface. Calculate the total of energy of the system. So we take out the information, which is M, mass equal to 50 gram, which is 0.05 kilogram. Spring constant K equal to 35 Newton meter per second, and amplitude equal to 4 centimeter, which is 0.04 meter. Number 1, the total of energy is equal 1/2 Ka square. So we substitute the value, we get 0.028 joule. Number 2, speed of the object at displacement 1.6 cm. So x is 1.6 cm, which is 0.016 meter. So we use formula V equal to omega square root a square minus x square. So omega formula, we can find omega with square k over mass. So we substitute the value, so we get 0.97 meter per second. So number 3, change in the period of oscillation if a load of a 6 gram is added to the object. So here we have to find two T, which is T1 and T2. T1 for mass 0.05 kg. We use formula T1 equal to 2 pi square m1 over k. So we substitute the value, we get 0.24 second. For m2, we have to add with 6 gram load, which is 0.05 plus 0.006. So equal to 0.056 kilograms. So we find the T using 2 pi square root 0.056 over 35. So we get 0.25 second. So to find the change in period, so T2 minus T1, so 0.25 minus 0.24. So we get 0.01 second. For number 7, A, why is the simple harmonic motion is a periodic motion without energy loss? The answer is because existence of restoring force and absence of dissipative force. So B, in an engine, a 200-gram piston oscillates in a simple harmonic motion with displacement varying according to xt equal to 5 cos 2t, where x is in meter and t is in second. So we take out the information, with this mass 200 gram, 0.2 kilogram, and xt equal to 5 cos 2t. So we get a equal to 5 meter and omega equal to 2. So question 1, write the expression for its vibrational velocity as a function of time vt. So v equal to dx over dt. So we substitute the value of x. So we get negative 10 sin 2t. So number 2, sketch the graph of velocity against time of the piston for the first complete cycle starting from t is equal to 0. So this is the graph. So first t equal to 0, and this is one cycle, and this is the amplitude 0. So to find the t, we use formula t equal to 2 pi over omega. So we get it's equal to pi, which is 3.14 second. So number 3, calculate the maximum acceleration of the system. A maximum equal to A omega second. So we substitute the value, we get A maximum equal to 20 meter second negative 2. So last, calculate the total energy of the system, which is E equal to 1/2 m omega square A square. So we substitute all the value, and we get E equal to 10 joule.
So for the question 2 in addition equation, state that a body oscillates with simple harmonic motion described by the following expression, which is S is equal to 3 sin 4t, where S and t is displacement in meter and time in second respectively. So first we have to compare the expression in question. S is equal to 3 sin 4t with S equal to A sin omega t, and we get A equal to 3 and omega equal to 4. So for the first question, state that calculate the speed of the body. So we use formula T equals to 2 pi over omega. Then we substitute the omega value, which is 4, and we get T equals to 1.57 seconds. So for the P equation, A at T equals to 2 seconds. So first question, calculate the speed of the body motion. So first we have to derive the equation of velocity. V equals to dx over dt, and we get d over dt a sine omega t. Then since it's since, and we have to use formula A omega cos omega t. So we have to substitute the value of A, which is 3, and omega, which is 4, cos omega 4, and t. Then we get 12 cos 4 t at 2. Then we get V equals to negative 1.75 meter per second. So since at question 2 in B, we get V equals to negative 1.75. Then the direction of the body motion is to the left. Thank you.
Question number 5. Figure 9.4 shows a point P moving in uniform circular motion of radius A. The respective point projection Q on the circle diameter is represented by the dotted circle. The displacement of point projection Q from the circle center O is x. A. Sketch a graph of displacement x against time t. First, we plot a graph displacement against time t, and the equation is displacement equals to amplitude sine omega t. For B question, starting with appropriate displacement equation shows the point projection Q perform simple harmonic motion. From definition, A must be proportional to negative x. So first we derive displacement equation. X equals to amplitude sine omega t. Then we differentiate x, and we get V equals to amplitude omega cos omega t. Then we differentiate velocity, and the equation is A equals to negative amplitude omega square sine omega t. Then we substitute equation x into equation A, and we get the equation A equals to negative omega squared x.